Welcome to SUSECON Digital and welcome to today's session about SUSE Linux Enterprise Micro, or in short, SLE Micro. In today's session, we'll talk about what is SLE Micro actually, what features and architectures have we integrated into the product, what lifecycle can we provide to our customers, and how does SLE Micro fit into the SUSE product portfolio. My name is Daniel Rahn and I'm a Senior Product Manager at SUSE and responsible for SUSE Linux Enterprise Micro. Now let's talk about what is SLE Micro actually. We've designed SLE Micro as a product that enables customers to focus on running their workloads and not focus on administration tasks on an OS level. We've designed SLE Micro to be the invisible operating system. We really want to enable our customers to only focus on their workloads, not focus on the operating system. Relax and rely on a stable operating system that we are providing to you so you can fully focus on the innovation you are creating with your workloads. And we've done that by checking the requirements we see today in modern IT and modern infrastructure. Customers want to run their workloads from cloud to edge and not care about the operating system. The operating system needs to be there. It needs to be easy to deploy. It needs to be easy to update, easy to manage, and really be secure and easy to be kept secure, but all that with a minimum effort by the customer's IT department. And the same is true for the infrastructure that customers are looking to run their workloads on. It needs to be a smart infrastructure with minimal maintenance. It needs to be easy to deploy at scale, needs to be ready for containerized workloads, ideally for Kubernetes-based workloads, and also here needs to be always secure. With all that in mind, we've made up our minds about what can SLE Micro actually provide. We've designed SLE Micro as a small footprint, enterprise-grade, lightweight, immutable operating system that's optimized for embedded devices, edge use cases, and industrial IT. Immutable operating system here really means SLE Micro is running from a read-only root file system that cannot be changed during runtime. SLE Micro, in addition, is based on the code base of SUSE Linux Enterprise. So it inherits the mission-critical features that SUSE Linux Enterprise is providing to customers for many years already, and enhances those with an immutable design and additional security features that SLE Micro is first to bring to the market from SUSE. We've prepared SLE Micro also to be able to provide very long product support cycles to our customers. As mentioned before, our key focus on SLE Micro is really minimize the administrative overhead, enable our customers to focus on their workloads, not focus on operating system administration, but really on the workloads and the innovations customers are creating. Last but not least, SLE Micro really is a container host operating system. So it is perfect for containers. It is perfect for Kubernetes. It is built up from ground to support containers and microservices. With that in mind, we have defined the following use cases for the product. It's one single node container host as a default. SLE Micro comes with a container runtime that does not require Kubernetes. You can run container workloads on SLE Micro without being in a Kubernetes environment as a default. But you can also integrate SLE Micro in Kubernetes environments, primarily, of course, with SUSE Rancher RKE2 or K3s Kubernetes distributions, but we also support third-party Kubernetes distributions on top of SLE Micro. In addition to that, SLE Micro is also designed to be a KVM virtualization host. We've introduced KVM virtualization on SLE Micro to enable customers to continue running their legacy workloads on top of an immutable operating system. That way, customers can innovate and modernize their infrastructure by still continuing running their legacy workloads until they're ready to containerize them. SLE Micro also is a perfect guest in the public cloud. Our public cloud team is creating the images in the major marketplaces for customers to consume and run their container workloads in the public cloud based on an immutable operating system. And last but not least, we have, of course, focused on SLE Micro being a SUSE Manager client. The first support for SLE Micro and SUSE Manager was introduced in summer last year, and we continue to improve on that support with every SUSE Manager release going forward. Looking a bit closer at SLE Micro and the architecture and the features we've chosen, we see that we've introduced with version 5.0 that was released in March last year, the major features already that build up our architecture here. So SLE Micro is an immutable operating system. It runs from a read-only root file system and provides a mechanism to actually still install updates on it. It provides enhanced reliability for the operating system by being able to roll back to old snapshots and comes with a health check daemon that enables the system to automatically heal from certain conditions. We've also focused on improving the hardening and security footprint of SLE Micro by introducing a fully supported SLE Linux framework, including the policy required to run SLE Micro in SLE Linux enforced mode. With regards to manageability, SLE Micro is the first SUSE product to bring to market a web-based management option for the operating system based on the upstream cockpit project. And in addition to all of that, we also provide the real-time kernel on SLE Micro on Intel 64-bit and AMD 64-bit architecture in the standard subscription of SLE Micro without an additional subscription required. SLE Micro is available on 3 architectures today. It's available on the 64-bit Intel and AMD architecture, on the 64-bit ARM architecture, and on IBM Z. It provides the classical installation methods that you know from SUSE Linux Enterprise, the manual installation using YaST2, automated installation using AutoYast, and new with SLE Micro, we also support image-based deployments using pre-configured images that SUSE provides with each product release. SLE Micro can be used as a bare metal container host OS on standard server systems. It can be used as a KVM host, and it can be used within a virtual machine. And on top of that, of course, we do support SLE Micro in the public cloud. Please keep in mind that SLE Micro really is a container host operating system. It is not meant to be the base for your containers. If you're looking for a base for your containers, please take a look at the SUSE-based container images. With regards to automated deployment, as I mentioned before, we do support AutoYast with SLE Micro, but we are focusing more and more on Yomi, and that is introduced as a technology preview on SLE Micro. Yomi is a technology that customers may know from SUSE Manager. It's a framework for automated installation based on SaltStack. And we've chosen to implement that with SLE Micro. Yomi configuration can be done with easy to create and easy to understand YAML files. And if you are interested in learning more about Yomi, please check the upstream page that I've referenced here for you. I mentioned the image-based deployment option with SLE Micro. We see that a lot of customers really focus on using pre-configured images for deployment of the operating system and not so much the manual or automated installation from ISO images. However, when we create pre-configured images, naturally, many options we cannot set as a default. For example, we cannot set the root password. We cannot know what partitioning scheme you're trying to use. In order to address that, we've chosen a one-shot initial system configuration tool to be included in the pre-configured images of SLE Micro, and for that we've chosen Ignition. Ignition can be used to partition your disk, format the partitions, write configuration files, enable systemd services, and configure users and user passwords. It runs from the initial RAM system up in first system boot and configures the operating system partition as required by the configuration that you're providing. Ignition does only touch the subsystems and configuration files that you tell it to do so. It does not set any pre-configured values for configuration files or options that you do not set in your Ignition configuration. If you're interested to learn more about Ignition, please take a look at the project upstream page that I've listed here for you, or take a look at the SLE Micro documentation that provides guidance on how to create the Ignition file and how to deploy the pre-configured images of SLE Micro using Ignition. A bit more details on what did we do with a 5.2 release already here at this point. So when you use pre-configured images, you usually need to take a mass storage device, write the image onto that, then put the mass storage device into a system, then supply an ignition config and boot the system so that when the operating starts the first time, the ignition configuration can be evaluated. With a new release, SLE Micro 5.2, that was released in April this year, we've actually introduced an additional pre-configured image format that we call a self-deploying image. You are able to boot from that self-deploying image, and that image will then ask you what storage device to write the pre-configured image to. So that removes the need for customers to actually pull out storage devices off their target system to write the image to. They can now, with a self-deploying image, actually boot the system from a pre-configured image and then write the configured image to the system and start working with SLE Micro. As for the Ignition configuration file, please refer to the SLE Micro documentation that I've referenced here. You can create the Ignition configuration also with a container using Podman on a SLE Micro system or any other container host, as noted here in this example. I've talked earlier about SLE Micro running from an immutable operating system and us implementing a technology to actually be able to apply updates to that. The technology we've developed here is called transactional updates. Transactional updates enable us to apply updates in an atomic way, meaning updates are either applied successfully to the system or they are not applied at all. Transactional updates can run automatically in the background, and it does not impact the running operating system. That is because transactional update actually creates a new writable snapshot from the currently running root file system and applies all changes into that new snapshot. If at the end of the transactional update determines that the installation of updates was successful, then that new snapshot is turned read-only again and marked as the next snapshot for the next reboot. If transactional update determines that an issue was encountered during installation of the updates, then the new snapshot is simply discarded and removed. Bottom line, this, however, means that in order for updates to be activated on SLE Micro, the system needs to be rebooted every time. And for that, we've introduced a tool called Reboot Manager that you can configure to reboot when it's needed, and then when it works best for you, when you have a maintenance window, when you know that your host can reboot because you have no workload running on it. That's what Reboot Manager is there for, and you can actually control Reboot Manager from etcd in a Kubernetes environment. In addition to Reboot Manager, as I mentioned earlier, we've introduced a health check daemon to SUSE Linux Enterprise Micro. The health check daemon provides a basic system health check when booting up the system. It checks for errors in the boot phase, and depending on the configuration, reacts to those errors. The default configuration on SLE Micro will react in the following way. If an error is encountered while booting a new snapshot, a snapshot that we know has never been booted before, then health check daemon will actually automatically roll back to the previously working snapshot and reboot the system, so your system can continue running production. If health check identifies an issue on a snapshot that we know has already been booted and has run production, then it will try to restart services and reboot the system and eventually inform the administrator of the system so that the administrator can take a look and debug the issue. Health check can be extended by user-supplied scripts, and therefore can be enabled to actually check customer workloads that are supposed to run on SLE Micro. With regards to security, as I mentioned before, our focus on SLE Micro is on SL Linux. We provide SLE Linux as a default confinement framework. We do not support AppArmor on SLE Micro. However, we do also provide a fully supported policy for SLE Linux. The SLE Linux policy that we provide with SLE Micro covers all the packages and services that we provide with SLE Micro, and that enables customers to actually install SLE Micro with an activated SLE Linux in enforced mode. Our default images are set up to enable SLE Linux in permissive mode. Customers are, however, free and fully supported if they choose to automatically install SLE Micro with SLE Linux set into enforced mode. With SLE Micro, our focus shifted away from using YaST2 for basic system management. SLE Micro usually is a system that is in remote locations or does not have a keyboard or monitor attached. And therefore, we were looking for a tool that enables customers to remotely manage the system if they have a desire for that. And for that, we've chosen a web-based option based on the Cockpit project. The Cockpit project is new to the SLE product portfolio, and SLE Micro as the first product to introduce Cockpit to our SUSE customers. And we've chosen a small but reliable set of modules initially. So we provide basic user management, basic container management for Podman-based containers. We provide a Cockpit module for virtual machine management. We also provide a Cockpit module for the network configuration management, log file access, and last but not least, remote system access, meaning a web-based shell to the system. Cockpit is an optional feature in SLE Micro. Customers are not required to enable Cockpit in order to receive support from us. As I mentioned, SLE Micro is running from a read-only root file system. It's an immutable operating system. That also brings some challenges when debugging issues on SLE Micro. Because if you need to install a tool to debug an issue that you've encountered on the operating system, that would require you to reboot the system. That, as we all understand, can actually lead to a situation where you cannot debug a situation or an issue on the operating system because a reboot may remove the condition that created that issue. And for that purpose, we've introduced a new tooling on SLE Micro. The command is called Toolbox, and it is using a Toolbox container, a small privileged container based on a SLE-based container images that you can start on SLE Micro to perform your debugging purposes. Within that container, which inherits the SLE Micro registration and gets access to the SLE update and software channels, you can install the software that you need for debugging, perform your debugging, collect the log files, send the log files to SUSE support, and when you're done, just exit the container. The container image is persistent across usages, so there's no need to reinstall your debugging tools the next time you need to debug something on SLE Micro. The Toolbox container is hosted on SUSECON registry, and every SLE Micro system can access that Toolbox container freely. With that, let's take a look about the architecture that we've talked about in this session. Again, SLE Micro is based on a SUSE Linux Enterprise 15 code base. We cover 3 hardware architectures with SLE Micro: 64-bit Intel and AMD, 64-bit ARM, and S390. SLE Micro provides an immutable operating system based on ButterFS, here based on this SLE 15 common code base. We are using the SLE kernel, and we are enhancing the SLE experience with a Podman as a default container runtime, the Toolbox container for easy debugging, the health check daemon to enable the operating system to automatically heal from certain conditions, and we are hardening this by using SLE Linux with a fully supported policy. For deployment of SLE Micro, we are offering Ignition as a one-shot configuration tool for the pre-configured images, and as optional features for SLE Micro, we offer Cockpit web-based management and a real-time kernel on the Intel 64-bit architecture. With SLE Micro 5.1, in addition to the features I already mentioned from the initial release, we've extended SLE Micro actually by adding support for kernel live patching, which is included in the SLE Micro priority queues, the integration of self-contained system tools, meaning a rewrite of SUSECON Connect, and we've extended the support lifecycle to 4 years of general support for SLE Micro. Every SLE Micro release starting with SLE Micro 5.1 will receive 4 years of general support. And the latest release, SLE Micro 5.2, extends on that by adding the also already mentioned self-deploying ISO for 64-bit Intel AMD systems to be enabled by default. We've introduced a new cockpit module for the KVM virtual machine management and actually improved the public cloud integration of SLE Micro. We've also focused on adding FIDO device onboard client as a new standard in SLE Micro 5.2, and we've really focused on providing many package updates and bug fixes on the new release. A few examples here, we've updated the cockpit framework to the latest upstream release that came with the removal of a cockpit dashboard, but overall provides a really modern and solid base for the cockpit web-based system here. We've also updated the Podman container runtime. With that update, customers can actually use Podman to run Kubernetes workloads on a non-Kubernetes distribution. This is of interest in certain situations when you're running on a system with very few hardware resources, where a full-blown Kubernetes distribution might not be suitable. We've also updated the transactional updates implementation in SLE Micro that has now added a dbus interface that customers can hook into with their management solutions. And coming soon as a maintenance update, we will be adding a module to Cockpit that enables the customer to manage the software updates via the Cockpit web management system. Also new with the introduction of SLE Micro 5.2 is SLE Micro for Rancher 5.2. SLE Micro for Rancher is a custom created images, purpose-built really for the use with SUSE Rancher. It's an OCI image hosted on registry.suse.com. It's free to use and free to redistribute with SUSE Rancher deployments. And will be used with upcoming SUSE Rancher deployment capabilities. SLE Micro for Rancher reuses the existing SLE Micro SKUs. So there is no separate pricing. It reuses the standard SLE Micro pricing. Now let's talk a bit about the SLE Micro lifecycle. The initial release of SLE Micro 5.0 had a limited lifecycle of 1 year. Starting with SLE Micro 5.1, we have, however, extended that lifecycle to 4 years of general support, and we will continue to provide 4 years of general support per release. So every SLE Micro release will come with a standard of 4 years of general support. And you can see here, we actually released 2 versions of SLE Micro per year. We have one release in spring that is meant as a stabilization and consolidation release, and we have a second release in fall that we use to rebase to the latest SLE Common Code with Service Pack and add intrusive new features and great new features that support our customers. When we look at SLE Micro in the SUSE product portfolio, SLE Micro is really focused on embedded edge and industrial IoT use cases. It integrates well with SUSE Manager, as I mentioned before. It's currently not available on IBM Power, but can be used in the data center in addition to edge or embedded use cases. SLE Micro really is there for customers that have a specific use case of running containerized workloads. SLE Micro, again, let me repeat that, is not meant to be the general purpose operating system that caters to every use case. SLE Micro caters to specific isolated use cases and requires the workloads to be able to run in containers or in virtual machines. But if your workload supports that, SLE Micro is a perfect solution from the SUSE portfolio. Bottom line, our SUSE Linux OS offerings are from base to bespoke. We have a SUSE Linux Enterprise common code base that we build our products from. The code base to serve your needs, our customers' needs. From that code base, we built SUSE Linux Enterprise Server, the gold standard for mission-critical workloads, and we also built SUSE Linux Enterprise Micro, the lightweight and secure platform for the edge on containerized or virtual machine workloads. So from the SUSE Linux Enterprise code base, we create the products depending on your use case and your needs to cater and support your requirements. It's basically your Linux and your lifecycle. It is your choice, and we are happy to welcome you as customers to our products. With that, thank you very much for your attention, and I wish you a continued success and a great SUSECON Digital 2022.